we're going to be scientists. We're going to walk through this door. We're going to start doing science. Before you walk through that door, I want you to know we're only looking for natural causes to natural events. We're not going to allow any supernatural events. Now you can go walk through the door into the science room. You see what I'm saying? That they're assuming it. And when you take away that assumption and actually ask whether life happened by chance, you get a whole different answer than you do when you're just asking how life happened by chance. Because how life happened by chance is assuming that it happened by chance. And it may not be. Okay, so anyhow, this monkeys and typewriters, where this comes from, Richard Dawkins, as we were saying, wrote this in his book, The Blind Watchmaker, was talking about whether or not life could have happened by chance. And Paley was he was actually a theologian, I believe, back in a couple centuries ago. He came up with an idea that many people have talked about, and it's called Paley's watch. Anybody heard of Paley's watch? Paley came up with this idea. He said, if you're walking along the beach or in the woods or something, and you see this little shiny object down on the ground, and you pick it up and you think, could this just be a rock? You know, a piece, maybe it's got gold in it or something. And you pick it up and you put it out your ear and it's ticking. Tick, 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 tick. And you open up this little shell. It's built like a shell, and there's a glass case inside, and there's a little thing going tick, 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 tick. Are you going to look at that and say, boy, that is really something? The wind and the rain and the weather put this whole thing together, made these gears that are all shiny and clean, and made them all. And then the thing is, the little escapement mechanism and the thing is wound up and everything. No, you'd say somebody lost his watch. Somebody designed this watch, and somebody lost a watch. It would not even occur to you to think that that happened by chance. And the reason why gets into the statistics. It's too doggone complicated. You look at a watch. Ever looked at a watch? Well, you know, my grandfather gave me a watch once, and I took it apart and broke it, of course. But that was, my dad got mad at me because I was an engineer. You know, I wanted to take things apart and figure out how they worked, and I couldn't always get them back together. I took apart radios and watches and everything else. But anyhow, they're very, very complicated inside. Everything's got to be just the right mechanism and everything, the bearings and springs and everything else. And that it would be no. If you have come to the assumption, come to the conclusion that that was not made by chance, you're absolutely right. Your intuition is giving you the right answer there, and you don't have to go off and do a scientific investigation to find out, because it is so impossible to make a watch that way. So, okay, and what I want to show you here is a program that will let you see that even a very simple thing like writing "methinks it is a weasel" would never happen by chance. Is anybody here good at shuffling cards? Do we have somebody that can just shuffle these cards? I'll give it a couple shuffles. But is there anybody here? Would you just shuffle these a few times just to get them in a good random order? Because we want, oh, watch, we're going to see whether she plays poker every Friday night.
These are new.
Yeah, they're brand new. They're the ones you should be able to go. So, there you go. Yes. So anyhow, as she's shuffling these cards, she's putting them in a random order. Now I want you to know something. It's an interesting thing about a deck of cards. I'm using a deck of cards mainly because it's something that we're all familiar with. You've all played with them and so forth. You know what the idea. How many cards in a deck of cards? 52. Okay. How many permutations? You know what a permutation is? A permutation is a different ordering of the deck of cards. How many different ways could we put a deck of cards into to produce a different permutation? Anybody have an idea? There's a number for that. If you have a calculator at home or on your cell phone or whatever, you can look at it and see that when in the more higher level functions, there's an exclamation point. You ever wondered what that exclamation point is on there? That's called a factorial. And the number of combinations, God, thank you very much. The number of combinations of a deck of cards is 52 factorial. And the reason for that is because you can take these cards and put them into a bag and shuffle them all up as we've done, and then pull one out. What are the chances of getting a particular card, say the ace of spades on the first lift? 1 in 52. But now you've got 51 cards left. So what are the chances of getting the king of spades as the second card? 1 in 51. Okay, so now the chance of getting both of those is 1 in 52 times 1 in 51, which is you know, you're getting a large number there, 2,500 or so. Now, next one would be 1 in 50, and then 1 in 49, and 1 in 48. And so that number is 52 factorial. And that number is huge. It's about 8 times 10 to the 67th power. It would be an 8 with 67 zeros after it. You could have a hard time writing that number out. But so if I were to take this deck of cards, and I think you know what I'm doing here, so shh. but if I were to just take off the top card of this freshly shuffled deck of cards, what are the chances that the first one would be the ace of spades? My goodness, how did that happen? Well, the chances are 1 in 52, right? So, you know, but that can't happen. The next one wouldn't be the king of spades, would it? Oh, man. How could this be? The queen of spades?
You didn't shuffle very good.
Yeah, she's not a good shuffler. Jack of spades? My goodness, what is going on here? Well, of course.
He has another deck.
Yeah, I have 2 decks of cards here, and that's why I was saying she probably saw me switching decks here. But you know, you would have enough evidence there that I was cheating just by the fact that I was going against the alphabet probabilities, right? That's just like to bring it home right now. They're counting ballots, and some of the ballot groups are coming in 160,000, I think it is, Biden votes and 0 Trump votes. That's the same kind of thing. On the face of that evidence, called prima facie evidence, you know that there's some hanky-panky going on there, right, just by that fact. Well, that's all information, and that's you know what scientists often are working with. Well, so that's what I've made this program to try and do, because when we're talking about the origin of life, we are talking about, first of all, I went on Wikipedia, and I pulled off a quote from there. When we're trying to produce a life, the scientists are trying to figure out how we could create life from non-life, because it had to happen at one point, right? There had to, especially from a natural point of view, if you want to take God out of the picture, this universe, which we don't have any reason to we have wonder why this universe exists at all, but assuming that it exists, at some point there should have been no life, and then life happened. The number of combinations of a deck of cards is a number that's called a factorial. If you look on your calculator, there's one button on your calculator, if you have a scientific one, that's got an exclamation point on it. You ever wondered what that was for? That's the factorial button. If you push that button, if you put in 1 factorial, the answer is 1. 2 factorial is 2. 3 factorial is 6. It's 2 times 3. 4 factorial is 24. 4 times 3 times 2 times 1. 5 factorial, it goes up like that. It would be 120. And so this number is, each one is bigger than the next one. Well, the number of permutations of a deck of cards is 52 factorial, because there's 52 cards here. You take these 52 cards, you put them in a sack, just randomly put them in there, and you reach in, you pull out a card. And you're looking for a specific order. Maybe just say you wanted them to be in poker order, you know, ace of spades on the top. So you pull it out. This is an ace of spades. What's the chances of that? Well, it's 1 in 52, because there's 52 cards. Now you got to go and reach another one. There's only 51 cards left, so it's 51. And so that now the chances of getting that first one right and the second one right is 1 in 52 times 1 in 51. And then the third one is 1 in 50. And next one's 1 in 49, and so forth. And as you go down, it gets to be a pretty big number. So here's the chances that we have here. 52 factorial. There's that 52 with the exclamation point. The number, if you put it into your calculator and push the button, it'll come out about 8. It's about 8 point something times 10 to the 67th power. Well, how big is that? Well, it'll take a moment for it to print that out to actually show you how big it is, because it's got to put an 8 with 67 zeros after it, and that is a stupendously large number. In fact, it is so large that as I said before, if there was a combination of these that would spring to life, we would never have found it, and we never will find it. It's that impossible. You finished? Looks like I finished. Okay. It's because, I'll give you an example. If you were to take 1 trillion people, how many people have ever lived on Earth? Doesn't matter if you're an evolutionist or a creationist, you would say around 100 billion, because they both agree on it. That's about the number. Well, a trillion is 10 times that. If you take 10 times the number of people that have ever lived, give each one a trillion computers. Okay, that's 1,000 million billion trillion. That's a huge number, 10 to the 12. And then let each one of those computers compute a trillion times a second, shuffle numbers inside the computer, a trillion times a second for a trillion years. How long has the Earth been around? Well, we would say around 6,000. An evolutionary, secular evolutionist would say around 13 point something billion years. This is a trillion, so this is 40, 50 times what that is, okay? So you do all that, you do all that, your chances of finding that combination I was talking about would still be 1 in a trillion. That's how impossible it is. Because a trillion is 10 to the 12th, a trillion people, a trillion computers, that's 10 to the 12th. A trillion times a second is 10 to the 12th. For a trillion years is 10 to the 12th. That's 10 to the 48th, because when you multiply exponents, you just add the exponents. I don't know if you know that. That's 10 to the 48th, and then you have to convert from seconds to years, because you were doing everything in seconds, and then you went shift to years, and that's another 7. So you get about 10 to the 56th. Well, this is 10 to the 67. You're still off by 10 to the 12th. That's a trillion. So your chances of finding it is 1 in a trillion. It's just not going to happen. That's how these numbers, when they get big like this, just a little deck of cards. And the amount of information that you can hold in this deck of cards is about 28 bytes. You know about what a byte is. You can write something out at 28 bytes. That's about what you could write out, is about 28 bytes with the information that's in here. That's not enough to produce life.